In this video, I'm gonna go over some problems from trigonometry, and we're gonna solve those problems either using the unit circle or if you remember the values. Okay, so this is the first problem. We're gonna find the value of sine at 45 degree, and the second problem is the value of sine 105 degree plus cosine 105 degree. Then we're gonna solve this problem. That's where they give you the value of a, b, and c, and they said find what should be the value of a plus b plus c raised to power a plus b plus c. That's a fun problem. And then this one, so they give you three angle and their sum is pi, and then they said prove that sine square alpha plus sine square beta minus sine square gamma is equal to 2 sine alpha sine beta cos gamma. Okay, so let's start with our first problem. So how I will tackle this problem? So here they ask me to find sine 15 degree. You can use your calculator to find it. What if they said find this value using a unit circle, or without using calculator, or just show your work how you find sine 15 degree? So I don't remember what should be the value of sine 15 degree, but I'm trying to change this sine 15 degree to the values that I can look from the unit circle. For example, if they ask me what will be the value of sine 30 degree, you see this angle here is 30 degree, and 30 degree, when they are asking sine is basically the y value, which is 1/2. And if they ask you what will the value of cosine 30 degree, that is the x value at 30 degree, which is because cosine is along the x axis, so which is root 3 over 2. So there are certain angles which we can find the values for trigonometric functions. They are given to us from this unit circle, so I'm gonna use that. So how we can break down this 15 degree to these known numbers or known angles? So look at this. So sine, I can write 15 using 45 and 30. How? So how about 45 degree minus 15 degree? And we know 45, sorry, not 15, 30. 15 we needed. Okay, my mistake. So 45 minus 30 degree. So that will give you 15 degree. And now I just need to write the t ratio or a trigonometric identity like sine of a minus b. So that is basically sine a cosine b minus cosine a and sine b. Okay, so we can write our values using this trigonometric identity, or they call it t ratio, different names. Okay, so sine 45 minus 30 can be written as sine 45 degree into cosine 30 degree minus cosine 45 degree and sine 30. Okay, so let me make space over here. So just look at this. So we changed our sine 15 degree to some known values that we can put in using a unit circle. So let's look at that. What should be the value of sine 45 degree? So look at the unit circle. At 45, sine means the y value, which is a root 2 over 2, which can also be written as 1 over root 2 comma 1 over root 2. How? Let me show you. So root 2 over 2 excuse me, so root 2, 2 can be written as multiplication of root 2 into square root of 2. See, so these will cancel each other. You're left with 1 over square root of 2. Okay, so sine 45 is 1 over square root of 2. How about cosine 30? So 30 degrees here, cosine is x value, so which is root 3 over 2. So cosine 30 is root 3 over 2 minus now cosine 45. So the interesting thing is at 45 degrees sine and cosine have the same value. So cosine 45 is also 1 over root 2, which is basically the x value here, or this one. Then sine 30, and sine 30, so sine is y value, so sine 30 is 1 over 2. So if I rewrite this, this can be written as square root of 3 over 2 square root 2 minus 1 over 2 square root of 2, and same denominator, so common denominator is 2 square root of 2, and in the numerator we got square root of 3 minus 1. So your sine 15 degree is basically equal to this value. You can use calculator to solve this if they ask you, or you can otherwise leave your answer as it is. Okay, so the other problem is sine 105 plus cosine 105 again. So I don't know what will be the value of sine at 105. What I can break that down into two known number which I can find the value from the unit circle. Let me write that problem on this page, that way it will be easy to look at the unit circle. So let me make a space over here. So what we got? Okay, so we got sine 105 degree plus cosine 105 degree. They said find the value. Okay, what should we do here? So 105, I can use 90 plus 15. That will give me 105, and sine 15 we already found that value in our previous problem. Okay, so let's write that down. So you can say sine 90 plus 15 degree plus cosine 90 plus 15 degree. Okay. So now we can use sine A plus B identity. Let me write down that over here. Sine of A plus B is equal to sine A cosine B plus cosine A sine B. And this one is cosine A plus B. I'm going to write that down too. Cosine A plus B is cosine A cosine B minus sine A and sine B. So we're going to use these t ratios or identities over here. So let's write down first for sine A plus B, which is 90 plus 15. So that can be written as sine 90 degree into cosine 15 degree plus cosine 90 degree and sine 15 degree. And then we got this plus sign over here. Now we're going to write the values for this. So cosine 90 plus 15 is cosine 90 cosine 15 minus sine 90 and sine 15 degree. And now look at the unit circle. What is the value of sine 90 degree? Look over here. So 90 degrees here. So at 90 degrees sine is basically the y value, which is 1. So we got sine 90, so 1 value. So sine 90 is going to be 1 times cosine 15. Leave it as it is because we're going to work on this as we did in previous example, plus how about cosine 90? Cosine at 90 is basically this x value is 0. So 0 times sine 15 gives us 0. Then we got cosine 90. So cosine is at 90 is again the x value, which is equal to, so this is 0 here. Cosine 90 is 0. So 0 times cosine 50 gives you another 0. Now we got, sorry, it's going to be minus sine. So minus, what will be the value of sine 90? So sine 90 was 1. So 1 times sine 15. So we got sine 15 degree. Sine 90 is 1. Sine 90 is 1 here. So we left with cosine 15 degree minus sine 15 degree. Now we can approach these two parts as we did in our previous example. So we can break down 15 into known numbers from the unit circle, which is basically 45 minus 30. So let me write that down. So we can write cosine as 45 degree minus 30 degree minus over here sine of 45 degree minus 30 degree again. So now we're gonna use again the t ratio. So cosine a minus b is basically, see, this is cosine a plus b, it's a minus sign. So cosine a minus b is just opposite, so you flip the sign, this becomes positive. Let me write that down. So a minus b is cosine a cosine b, just flip this to positive, sine a sine b. That's how I remember these t ratios. Okay, so cosine 45 minus 30 can be written as cosine 45 degree cosine 30 degree plus sine 45 degree sine 30 degree. Then we got this minus sign here. I'm gonna put parentheses just to separate them out. So sine 45 minus 30 is sine 45 degree cosine 30. Then we got, again, this is plus, this is plus. If this is minus, just change this to minus. That's how you can like remember or memorize the formula. Minus cosine 45 and sine 30. Okay, now just we need to plug in the values from the unit circle. Cosine 45, okay, this is 45. Cosine 45 is the x value, which is 1 over root 2. So you got 1 over root 2. Cosine 30, this is 30, x value is root 3 over 2 times root 3 over 2 plus sine 45, which is equal to cosine 45, which is 1 over root 2, and sine 30, sine is the vertical or the y value at 30, which is 1/2. So you got 1/2. Okay, minus cosine 45 is again 1 over root 2, and cos 30 is the x value at 30, which is a root 3 over 2. So let me write x is basically cos theta and the y is sine theta. Okay, so x value at 30 is this root 3 over 2 minus cos 45, which is again 1 over 1 over square root of 2, and sine 30 is going to be 1 over 2. Alright, so now simplify it. So this gives me square root of 3 over 2 square root of 2 plus 1 over 2 square root of 2 minus square root of 3 over 2 square root of 2. This minus multiplied by minus gives you plus. So this gives me 1 over 2 square root of 2. So you see, this is positive square root of 3 over 2 square root of 2, and this is negative. So they'll cancel each other out. And we left with 1 over 2 square root of 2 plus 1 over 2 square root of 2. So common denominator is 2 square root of 2 and 1 plus 1 on the top. So this gives me 2 over 2 square root of 2. So this 2 will cancel this out, and we're left with 1 over square root of 2. So the value of sine 105 degree plus cosine 105 degree is 1 over square root of 2. Alright, let's move to the next example. This one we already did, so we are on this one. So they give you a, b and c, and they said find a plus b plus c raised to power a plus b plus c. So it looks very confusing, but it's very simple problem. So let me write that down. So a is equal to secant 4 theta plus tangent raised to power 4 theta minus 2 secant squared theta and tangent squared theta. I'm gonna write one identity over here. So if you guys remember from algebra, I believe a minus b square is equal to a square minus 2ab plus b square. How about a plus b square, which is equal to a square plus 2ab plus b square. Now look at this example over here, the value of a. It looks something like this value over here. Okay. So what we can do in this situation, if I write secant raised to power 4 theta as secant square theta square plus tangent square theta square minus 2 secant square theta tangent square theta. So that looks like this. See, a square plus b square minus 2 times a, which is secant square theta, times tan square theta, which is b. So this is basically a square plus b square minus 2ab, and this is equal to a minus b square. So I can say this whole these three numbers or whatever trigonometric functions, they can be written as secant square theta minus tangent square theta whole square. And from trigonometry identities, we know secant square theta minus tangent square theta is equal to 1. So basically the function inside the parentheses are equal to 1 and then square, that gives me 1. Alright, so the value of a is just 1. Now let's find the value of b. That'll be interesting. So b is cosecant 4 theta plus cotangent 4 theta minus 2 cosecant square theta cotangent square theta. Okay, so same thing, a square plus b square minus 2ab. I'm gonna rewrite it as cosecant square theta square, because when you bring square in, it will give you cosecant 4 theta. So same thing here, cotangent square theta square minus 2 cosecant square theta cotangent square theta. That can be written as cosecant square theta minus cotangent square theta whole square. Okay, and from trigonometric identities, cosecant, not cosine, cosecant square theta minus cotangent square theta is equal to 1. So this gives me 1 square is equal to 1. So b value is also equal to 1. Now let's find out c. C is sine raised to power 4 theta plus cosine raised to power 4 theta plus 2 sine theta cosine theta. I'm gonna do the same thing. So sine square theta whole square plus cosine square theta whole square plus 2 sine theta cosine theta. So this can be written as sine square theta plus cosine square theta raised to power 2. So this identity there, or the formula. And in trigonometry, sine square theta plus cosine square theta is equal to 1. So we got 1 square, which gives me just 1. So C is also equal to 1. So what should be the value of a plus b plus c raised to power a plus b plus c? So a is 1 plus b is 1 plus c is 1 raised to power 1 plus 1 plus 1 gives me, put parentheses there, I believe, make it more sense. So that gives me 1 plus 1 plus 1 is 3 raised to power 3, which is 3 times 3 is 9 times 3 is 27. So that is my answer. So a plus b plus c raised to power a plus b plus c is equal to 27. That's the value. All right. So practice more. So as you practice, you'll be able to remember these t ratios, these trigonometric identities, and when you see a problem, you immediately know what you need to do. For example, these little tricks over here, the more problems you will work with, the more familiar you will get with these ideas or tricks. Okay, so let's go over example 4. So here we got alpha plus beta plus gamma is equal to pi, and then prove that sine square alpha plus sine square beta minus sine square gamma is equal to 2 sine alpha sine beta cosine gamma. So what I'm gonna do, whenever I see problems like this, I either choose the left hand side and prove it to right hand side, or vice versa. So in this example, I'm gonna use the left hand side, which is sine square alpha plus sine square beta minus sine square gamma, and I'm gonna change or convert or make it equal to right hand side. Okay, so in this problem again we need to use a lot of t ratios. So we got sine square alpha. I'm gonna leave it as it is. How about sine square a minus sine square b? So that is sine square a minus sine square b, that is equal to sine of a plus b into sine of a minus b. Okay, so what we got for these two numbers, we got sine beta plus gamma, because my a is beta and my b is gamma. I'm leaving sine square alpha as it is, just working with these two first. Okay, times sine beta minus gamma. Okay, now sine square alpha plus, what is the value of beta minus gamma? Look at this. Beta minus gamma is pi minus alpha. We need to subtract alpha from both hand sides. So we got sine of pi minus alpha into sine of beta minus gamma. And if you remember, sine of pi minus theta is basically equal to sine theta. So this sine of pi minus alpha can be written as just sine alpha. So sine alpha into sine of beta minus gamma. Now look at these two parts. They both have a common factor, which is sine alpha. So if I take out sine alpha as a common factor, then I left with sine alpha, because from sine square alpha, if I take out sine alpha, I left with sine alpha plus, and I took sine alpha out from the second part, so I left with sine of beta minus gamma. All right. So now this is beta minus gamma, this is alpha. Can I write alpha in terms of beta and gamma? Yes, so alpha can be written as pi minus beta minus gamma, or pi minus parenthesis beta plus gamma. I just took the negative sign out. Okay, so let's do some more math. So left with sine alpha, and sine alpha inside can be written as, I'm not playing with this sine alpha because I need one sine alpha, so I'm leaving it as it is. So I already got one part of my right hand side, so I'm trying to bring these two and this number 2. So that's what we're gonna do by playing with these functions over here. So sine alpha can be written as sine of pi minus beta plus gamma. Okay, this plus sign, sine of beta minus gamma, parenthesis. Now I'm going to use this formula again. Sine of pi minus theta is basically sine theta. So sine of pi minus beta plus gamma is going to be just sine of beta plus gamma. So my equation keep becoming more simpler. So sine of beta plus gamma. I did this trick over here because I want to change this alpha into beta and gamma, and then I can use some t ratio to work on it. That's why I played this trick over here. Okay, so sine of beta minus gamma. Now I'm gonna use this t ratio, sine of a plus b plus sine of a minus b, and that is equal to 2 sine A cosine B. Okay, so I think we got the answer. So we got sine alpha, and instead of sine beta plus gamma plus sine of beta minus gamma, we can write 2 sine A, which is my beta, into cos B, which is my gamma. All right, so rearrange this, bring 2 forward as a constant. So I left with 2 sine alpha sine beta cos gamma, and that's what is equal to right hand side. So hence the proof. All right, so look at it. So as I said, pick one, either left or right. So left hand side, I see more options to work with. So I used trigonometric ratio to rewrite these functions, use some tricks from trigonometry, and we got the left hand side equal to right hand side. Again, I always encourage all my students, please practice more examples. If you're stuck at any problem, ask your teacher, ask your friends, or you can send me a message, or in the video leave a comment and I'll reply you back. Okay, so the more you practice, the more you work with these kind of problems, it will become more easier to you guys. All right, so thanks for watching the videos, and please do share with your friends, and please subscribe to the channel. That again, that encourage me, that make me make more videos, and thank you and have a good day. Bye bye.